Section 3 is solving polynomial equations. Solving polynomial equations this time, not just roots and zeros. Really, you've been doing this all along anyway. You just need to basically remember how to do it. So here we go. What is the y-coordinate at any x-intercept?
0.
X-intercepts are where the graph crosses the x-axis. And where the graph crosses the x-axis, the y-coordinate must be 0. That concept right there is critical that you understand. That is why we set our equations equal to 0 when we're trying to find roots or zeros or solutions. To solve a polynomial equation by factoring, it means find the zeros. It means find the x-intercepts. It means find the solutions. It means find the roots, which we've already been doing. So set the equation equal to 0. Let y equal 0. All right, you have your equation. You have y equals some stuff, or f of x equals some stuff. Set it equal to 0, and then solve for x. To solve the equation, we're going to factor the equation most of the time. In this section, we're going to be factoring the equation all of the time. Use the zero product property to split your factors up and solve for x, just like we've been doing. You may need to use the quadratic formula. It could be that you wind up with some sort of trinomial, quadratic trinomial that does not factor, and if that's the case, use the quadratic formula. Number 6 is probably the most important thing. All roots must be accounted for, real or imaginary. So we're going to get back into imaginary numbers in this section a little bit. We can have imaginary roots. If my quadratic equation does not cross the x-axis, then that means that there are 2 imaginary roots. If my 4th degree polynomial crosses the x-axis only twice, then that means that there are 2 real and 2 imaginary roots. And when you have imaginary roots, you're going to be forced to use the quadratic formula because you can't factor a problem if it has imaginary roots. Find all the solutions to each equation. So for that first equation, how many solutions should I have? 3. Maybe some are real, maybe some are imaginary, I don't know. Hopefully they're all real because then I can find them. So what should I probably do first here? Everything on one side, and then I'll have equals 0 on the other. And I'm going to write these in descending order. So I'll have 2x to the third minus 5x squared minus 3x equals 0. And it says find all the solutions, which is basically the same as find all the roots. So what do I need to do next? Okay, GCF here is x. And then I'm left with 2x squared minus 5x minus 3 equals 0. I want to continue factoring. Technically at this point with that quadratic in parentheses, I could use the quadratic formula on that if I zero product property this right now. But I like factoring better because factoring is usually a little bit faster. So can we factor that middle one, or that trinomial? How am I going to have to factor that thing? Yeah, if there is a 1 on the x squared term, then I can. But there isn't. I have a number here, which means I have to use the box. So I need AC equals what? -6, which means I need 2 numbers that multiply to give me -6 and add to give me -5. -6 and +1. So I'll write those down, and then I'm going to check it. That does multiply to give me -6, and they do add to give me -5, so I'm ready to go. So I set up my box. First box, first term, so 2x squared goes here. Last box, last term, so -3 goes there. And then the 2 numbers I picked with the variable attached, -6x, +1x. GCF across each row and down each column. For my top row, it's going to be just x. For my bottom row, it's going to be -3. For my first column, it's going to be +2x. For my last column, it's going to be just 1. So now it's factored. I have x times the 2x plus 1 times the x minus 3 equals 0. Now what? Yeah, you use the zero product property. There's actually three. We have the x equals 0. We have the 2x plus 1 equals 0. And then the x minus 3 equals 0. X equals 0 is already solved. For this one, if I subtract 1 from both sides and then divide both sides by 2, I get x equals negative 1/2. And on this one, we get x equals positive 3. One solution, two solutions, three solutions. I knew I should have three solutions because that's the degree of the polynomial, and I found all three. So I'm done. Second one, what should we do? Basically the same thing. So get everything on one side, write them in descending order. 3x to the fourth minus 6x to the third plus 12x squared equals 0. Now what? Okay, GCF here is what? It's what? X squared for sure, but notice that there's also a number, 3, 6, and 12. 3 goes into all of those, so I can actually pull out 3x squared. And then I'm left with what? Minus 2x plus 4 equals 0. Now what? Yeah, okay, good. So notice because we pulled the 3 out, now there's just a 1 here, which means I don't need to go to the box method. I can just think of two numbers right away that multiply to give me positive 4, and at the same time add to give me negative 2 are the two numbers that do that. In order for me to have two numbers that multiply to give me positive and add to give me negative, both signs must be negative. So I'm looking for two numbers that are going to add. Both numbers have to be negative. Two numbers that add to give me negative 2. The factors of 4 are just 1 and 4, or 2 and 2. Is this going to work? No. So does this factor? No, it doesn't. Which means, notice that it's a second degree polynomial sitting in there. I can use the quadratic formula for that second part. If it's not a second degree polynomial, then I can't use the quadratic formula. You'd have to factor it some other way. In this class, generally, you're not going to have that issue. All right, so we're going to use the zero product property on this right now. We have 3x squared equals 0, and we have x squared minus 2x plus 4 equals 0. Well, let's talk about this right here. What do we get? X equals 0 is the solution here. Incidentally, its multiplicity would be 2. If I divide both sides by 3, I wind up with x squared equals 0. X squared is the same as x times x equals 0. Zero product property on that gives me x equals 0, x equals 0. So the graph at 0 will look like a parabola, just to bring up the last section. So we have x equals 0 as one of our solutions. And now we have this x squared minus 2x plus 4 equals 0 for our other solution, but we have to solve. In order to solve, we're going to have to use the quadratic formula. So we write x equals. The quadratic formula, remember, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That just needs to pop into your head automatically. You got to know it. So I'm going to write what? So negative b, so negative negative 2 is positive 2 plus or minus the square root of 4. Minus 4 times 1 times 4. So that's minus 4 times a times c, and then it's all divided by 2a, so 2 times 1, which is 2. That's the setup for the quadratic formula. Now we simplify it down. X equals, the 2 sticks around, plus or minus, square root. We have 4 minus 16, which is negative 12, all divided by 2. Keep simplifying. X equals negative 2 plus or minus. What does the square root of negative 12 simplify to? Maybe we need to review how to do the square root of negative 12. This would be the square root of negative 1 times the biggest perfect square that goes into 12, which is 4 times 3, all divided by 2. So x equals 2 plus or minus. Now I simplify that root. The square root of 4 is 2. 2. The square root of negative 1 is I root 3 all over 2. And then notice that we have this factor of 2 here, here, and here, so I can reduce that to x equals 1 plus or minus I root 3. How many roots did I get there? 2. The plus or minus means I have 2 sitting there. How many roots did I get here? You see 1, but actually there's 2. So a total of how many roots? 4. And how many did I want? 4. So I found them all. You have to find all of them. With a problem that looks like this, they've already done some of the work for you. They've started to factor it already. They didn't give it to you in the standard form, x to the 4th, blah, blah, blah. Okay? This one is a 4th degree polynomial, though, if we were to FOIL it all back out. So that means we need 4 solutions. Right now, I can split this up into 2 separate things equal to 0. I can use the zero product property now. If I do that, then I have x squared minus 1 equals 0, x squared plus 4 equals 0. Now this thing right here does factor. That's the difference of squares. I could factor it into x plus 1 times x minus 1. Or I could use, since it's just x squared minus 1 term, I could move this term over here and then use the square root property on both sides. That's the way I'm going to go. I'm going to add 1 to both sides. X squared equals positive 1. And now I'm going to take the square root of both sides and I get x equals what? Well, the square root of 1 is 1, so I get x equals... No. No. When you take the square root of both sides of an equation, you take plus or minus 1. How many solutions did I just get there? 2. Over here, I can use the same idea. I can use the square root property. So I'm going to subtract 4 from both sides. X squared equals negative 4. And then square root both sides. And I get x equals what? Plus or minus 2i. Nice job. It's plus or minus because I took the square root of both sides of an equation. It's 2i because I took the square root of negative 4. Can't take the square root of negative 4, so I can take the square root of positive 4, as long as I call it I. How many solutions did I get total? 4. And I was expecting 4. So now on this last one, x to the 5th plus 4x to the 3rd equals x to the 4th minus 2x to the 3rd. What should I do? Everything on the same side. So let me change colors here just so I don't get confused. I'm going to write x to the 5th minus 5x to the 4th plus 6x to the 3rd. Those were like terms there, equals 0. Now what? GCF is x to the 3rd. And it's worth noting that you're going to have 5 solutions here. So our GCF is x to the 3rd times what's left over? Okay. Equals 0. All right. So now, what? Sure. Or I can split it up right now as well. I could write x to the 3rd equals 0, zero product property right now, and then x squared minus 5x plus 6 equals 0. So over here I can solve for x right now. What do I get? Basically that would be x times x times x equals 0, right? So x equals 0 with a multiplicity of 3. So how many solutions did I just find right there? 3 of them. I just need 2 more, and they're sitting over here with this x squared term. We use the letter n, mostly because that's what the book used, but you could say n equals 3 on that one. Now on this one, we can factor it if it factors. If not, then use the quadratic formula. Does this one factor? If it does, I need two numbers that multiply, give me positive 6, and add to give me negative 5. Negative 2 and negative 3. Negative 2 plus negative 3 is negative 5. Negative 2 times negative 3 is positive 6. So this one does factor. X minus 2 times x minus 3 equals 0. Now I can split that one up. X minus 2 equals 0. X minus 3 equals 0. So x equals 2. X equals 3. 3 solutions there. One more for a total of 5. So far in Algebra 2, you've learned several different patterns for factoring. We kind of saw a couple of those already. The difference of squares, perfect square trinomial, and sum of squares. The difference of squares was, if I have a squared minus b squared, I'm subtracting two perfect squares, then factored form would be a plus b times a minus b. The perfect square trinomial was, if I have a squared plus or minus 2ab plus b squared. I'm saying plus or minus because I could have a positive there or a negative there. The same pattern holds. Then that factors into a plus or minus b, the quantity squared, which is the same as, I can write that out fully like a FOIL problem. I can write that as a plus or minus b times a plus or minus b. So if I saw a positive sign there, it would be a plus and a plus and a plus. If I saw a negative sign there, I'd see a minus sign here, it'd be a minus b squared, or I could write it as a minus b times a minus b. We also learned the sum of squares when we finally learned about imaginary numbers and complex numbers. The sum of squares, like the difference of squares, except it says a squared plus b squared. And the sum of squares can factor using imaginary numbers into a plus b I times a minus b I. There's two more important ones that we have to know. It'll be incredibly useful to us if we know them, and it'll be incredibly useful to you if you memorize them. We have this binomial times a trinomial here. I want to FOIL or distribute that out. So to do that, you can do double distribution and then combine like terms, or you can use the box, which is the method I prefer. I would have an a here and a b here, and then an a squared here, a negative ab here, and a b squared here. Use the box by multiplying row times column to write the answer in the box, and then combine like terms from there. So that will give me a to the third here, negative a squared b here, and then positive ab squared here. Then a squared b here, then negative ab squared here, and finally b to the third here. Then we need to combine like terms. A to the third has no other like terms, so I write a to the third. Then I have a squared b. Letters and exponents have to match. The only one that matches is this one right here, negative a squared b. So positive a squared b minus a squared b is gone. Negative ab squared matches with this one, positive ab squared. And when I add those together, they're gone. I'm left with positive b to the third. So all of this multiplies out to give me that. Anyone want to take a guess on this one? No? It's not a to the third plus b to the third. That's what we got right there. It's a to the third minus b to the third. So without doing the multiplication, if you were to do the multiplication, you would get exactly a to the third minus b to the third. Because we demonstrated that these multiplication problems with letters and not numbers actually work, then that means that we can use them as rules just like we did with these rules up here. So now you know that a plus b times a squared minus ab plus b squared multiplies out to be a to the third plus b to the third. Likewise for this one. The sum of two cubes and the difference of two cubes. The sum of two cubes, the difference of two cubes. If you have this pattern here, you can factor it into that. If you have this pattern here, you can factor it into that. And I want to take just a minute or two to try to see the patterns that are involved in these. You need to know the patterns. If you know the patterns, you will always remember how to factor sums or differences of cubes. So what do you see? Okay, we have a plus and a minus here. So if I have a to the third plus b to the third, how am I going to remember? Like notice if I factor these, I have a over a, b, b, a squared, ab, b squared, b squared. All the letters are the same. So that means you're going to find each one of these positions the same way. Find this one by taking the cube root of that. What number times itself 3 times gives me that number right there? What number times itself 3 times gives me that number right there? Once I have these two numbers, how would I get that number? I got this number written down. Take this number and square it, and that gives me that number. How would I find this number? Multiply these two numbers together, gives me that number. And how do I find this number? Square. So that's the pattern of how to factor this thing. Figure out what number times itself 3 times gives you that. What number times itself 3 times gives you that. And that gives you those two positions. Once you get those two positions, then take that number and square it, it gives you that. Take that number and square it, it gives you that. And then take these two numbers, multiply them together to get that one. And that's true for either of these. The only other difference is what? The subtraction signs. How can we figure out where those subtraction signs go? That's right. The sign that you see here goes with the binomial here. So if I see plus, I'm going to put a plus there. If I see minus, I'm going to put a minus there. Notice that in each one of these, there's only one subtraction sign. If I've used the minus sign here, then there's going to be plus plus. Notice the last term is always plus. If I use the plus sign here, then there has to be a minus sign, and it has to go there. Okay? So those are your patterns for the sum of cubes and the difference of cubes. You need to know them, because I'm never going to give you this on a quiz or a test.